And then I'm going to hide some panels and things like that. There we go. That makes it a little bit better. All right, welcome to Thursday of week 1. I want to remind you that the homework, chapter 1 homework is due tonight, and that is for attendance purposes. So if you haven't already done it, make sure you get that done, as I have to, even if you're here in the meeting, I don't get a roster of who showed up in the meeting. So you'll just need to, and at least half the class doesn't come to the meeting because there's 65 in the class, clearly not 65 in the meeting. It's because it's hybrid web and Zoom. So make sure that you get that assignment done, and that way you don't get dropped from the class. Uh, Even if you start the assignment and don't finish it and then late pass it, it'll still be fine. You would still get credit for being here, for interacting with it. But I think most of the people in this room, looking at the names I can see, most of you have already done that, so disregard that. So today we're going to finish up section 2.1. There's just one little piece, just the pie charts. We're going to jump into section 2.2, and we're going to be organizing some quantitative data. We're going to look at some discrete data. We're going to do a histogram. I'll tell you about the difference between a bar graph and a histogram. We're going to organize our continuous data in tables, constructing a histogram. We're going to draw a stem and leaf plot and look at shape of distribution. After we do our lesson, we're going to go through lab 1. I'm going to walk you through how to do it, how the controls in the Excel work, what I'm looking for. So that's on the agenda for tonight. It looks like it's a whole lot. It really isn't going to take an incredibly lot amount of time. It won't be terrible. We'll still be done, probably 6:45-ish. Depends on if there's questions, but that would be my estimate of when we'll get done. All right, let's just jump right into it. All right, so this data right here represents the marital status in millions of US residents, 18 years or older, of 18 years of age or older. Man, I guess I can't speak. We look in 1990 and we look in 2006, and we are comparing these. So taking a look here, when we are going to be comparing them, we're just going to compare the data the way we have it. But if you're looking here, if you start looking at the numbers, if we were adding them together, you can kind of see that there are significantly more people in 2006 that were polled or that were mentioned than in 1990. So we're not exactly comparing apples to apples here. So it's, even though it shows that the widow is exactly the same amount, clearly, since there are more people in 2006, the widowed percent would be lower. So we're not really comparing apples to apples, but it still will be an interesting graph side by side. So, okay. We're going to take it and we're actually going to do relative frequency. So remember, relative frequency was the total number in that section divided by all of those sections added together. So I'm not going to make you calculate it. I'm not going to calculate it. I just trust me, I calculated it because this is a relative frequency histogram. I didn't actually show you the numbers. We just made our relative frequency histogram. So as I mentioned with the widows, take a look here. Whoa. Take a look here with the widowed. The widowed, the percent in 2006 is lower. I like the side-by-side bar graphs, and weeks, many, many, many weeks from now, because we're just in week 1, when you do your final project, you're going to have 2 variables. A lot of people use side-by-side histograms, and it makes it very interesting. But so take a look. Oh, I got to quit doing that. The never married here, we have a little bit more in 2006, and you can see that we're significantly more married in 1990. I really don't like that the color on my key here for 1990 is not the right color. You just know it's lighter, but I just now noticed that. That's kind of annoying. Sorry about that. All right. So a pie chart. You've seen so many pie charts, I'm sure, in your life. They are kind of fun to look at. They're a great way to quickly see which section has more. I really like pie charts. We are not going to do them by hand. Doing them by hand is a lot of work. So we're going to be doing them in Excel, but we're not going to do them by hand. So what a pie chart is a circle that's divided into sectors. Every sector represents a category of data, and then it's proportional to the frequency of that category. So if 50% of some whatever category is 50% of the people fall in that category, then you will see the half of a circle that is, or the semicircle that is going to be shaded for that. So let's take a look. So we're going to take just the 2006 of the people that were the marital status, and we're going to put it into a pie chart. Now, when we're doing our lab, I'm going to want you to put those percents on the pie chart. It is a lot easier to read when you have those percents on there, but I really like how pie charts, you could just quickly look at it and see, like, wow, married is significantly more than all of the rest of them. So if we did it by hand, you would have to use a protractor to measure the angles and figure out what proportion, like what is 50%, you'd figure out what 58% of 360 is, and then figure out what that angle is and draw it in. It is a lot of work. It's kind of satisfying once it's done, but obviously, as I said, I'm not going to make you do that. Any questions about pie charts? All right. All right. So we're going to talk about discrete data first. So remember, discrete data are things that are countable. So in this case, it is the number of available cars in a household. So we pulled 50 random people and we figured out how many cars each of them had available in their household. The reason we say available cars is because like broken down cars are not counting. It's cars that you can drive. So I put it into a relative frequency table. First, I did the frequency, which is right here. And then I did relative frequency so that I could make it a relative frequency chart or graph. So we see that people with 0 cars is about 8%. People with 5 cars was about 2%, and it varies in the middle. Now, as I said before, if you're making a frequency table, you don't have to do tally marks. Sometimes it's helpful. Sometimes I'll do that when it just make it easier to count. I will put a column for tally marks. You don't have to put tally marks unless you want to. So we're going to create a histogram. Most of the time, we use histograms for continuous data, though it is not unheard of for discrete data, but most of the time we will do it for continuous data. So a histogram has rectangles just like a bar graph. Every category or class of data has its own rectangle. The height of each rectangle, just like a bar graph, is the frequency or the relative frequency of that class. The width of each rectangle is going to be the same, but the difference here between the histogram and the bar graph is that those rectangles are going to touch each other. They go completely all the way across and touch each other on both sides. So the bar graph has that space between. And sometimes we'll put just, like a line between the bars or a tiny, tiny space there so you can see the separation, but you don't have to. It's okay if you don't, but sometimes, occasionally we will. And I'll show you some examples of that. So we're looking at the car data that we just had. So we figured out the frequency and we figured out the relative frequency. So here is my histogram. When it is discrete data, the categories are labeled in the center of each of the bars of the histogram if it is discrete. If it is continuous, this is not how we label it. We label it differently if it's continuous, but with discrete, we label it in the middle because the entire rectangle is 1 car or 2 cars or 3 cars. It's that entire rectangle. With a continuous data, we have a range of data in each of the rectangles, so we're going to label it a little bit differently. Sorry about that. Any questions so far? We doing good? If you have a question, just feel free to type it in chat, or you can just unmute yourself and interrupt me. I don't care. It's not going to make me mad. I'm not going to get irritated. It takes a lot for me to get irritated. I mean, I teach high schoolers all day, so you guys, there's no way you're going to irritate me as much as a high schooler. No, they're fun. I have a blast with them. They crack me up. I wouldn't do it if I didn't absolutely love it. Okay, I guess this was the frequency and this is the relative frequency. They look almost identical, but just like with the bar graph, it doesn't matter. Just make sure you label it and label it as frequency on the side. Label the tick marks. Also, you have to have a title. You need to have axis titles, horizontal and vertical. And with you're going to need to label what your bars are. Okay, moving on. Okay, so now we're moving into continuous. So classes are the categories in which the data are grouped. We also call them bins because Excel calls them bins. And so I have gradually worked to calling them bins more than I call them classes. It's the exact same thing. Classes and bins are the same thing. So when we have a large number of different discrete values, or if we have continuous data, we're going to have to create intervals of numbers. Because if I was counting, like for example, number of pages that are in all the books on my bookshelf, I'm not going to be able to give each one its own bin because that would be crazy because every single book on my bookshelf would have a different number of pages. So I might separate it into 300 to 349 and then 350 to 400 or to 399 and then 400 to 449. I might split it into bins like that. And then I'd have a range of values in each of my bins. Even though it's still discrete, I would have a range of values because there's a large difference in the middle of there. I think I have a good example of that. This is it right here. So the following represents the number of people ages 25 to 64 who are currently work disabled. Now, it wouldn't make sense for me to have a different bar on my histogram for 25, 26, 27, 28, all the way up to 64. It would not make sense to do that. So we put it into categories. So it's 25 to 34, 35 to 44, etc. So what a lower class limit is it's the smallest value within a class. So this right here, 25, is the lower class limit of my first bin or my first class. 45 is the lower class limit of that one. So the first number there is my lower class limit. The upper class limit is the largest value within that class. So for example, this bin right here, 54 would be my upper class limit. That is the highest value inside my bin. If I want to know the class width, you just take the two lower class limits that are consecutive and just subtract them. So 35 minus 25 is 10. There's 10 in each class. That's my class width. Questions so far? We doing okay? Hanging in there? All right. So right here I have the number of, so I have the data represents the time between eruptions of Old Faithful Geyser in Wyoming. So this is all of these times. I'm not asking you to put it in your calculator or write it down or do anything with it. I'm going to split it into classes. So I took all of this data. It is raw. I haven't cooked it yet. I haven't organized it yet. It is just hanging out there. So the smallest data value is 672. So they call it finding a convenient number. I say find a pretty number. When I create a histogram, I find a pretty number that's just a little bit lower than the smallest data value. So our smallest data value is 672. So I'm going to start my lowest class at 670 because I want it to be at a nice pretty number. And then I'm going to use a width of 10 to obtain my classes. It's going to be 670 to 679, 680 to 689, etc., etc. My last class will contain the 738. I'll show you what it's going to look like. Looks like this right here. So these are the bins that I've created. I decide how wide they want to be. I move my lowest value just a little bit so that it can start on a nice pretty number. You don't have to start on a pretty number. In fact, when you create a histogram in Excel, it's not going to put it at a pretty number. It's going to give you whatever your lowest data value is. that's where it's going to start your lowest class. You can change that. I will show you ways to tweak it and make it pretty because statisticians always like to make things pretty. Trust me. But if it's between pretty and functional, we will go with functional first. But pretty is something that we like to do. We like things to be visually appealing. You will see as we're going through choices for your histograms. All right, so since my highest value is 738, notice it does fit in here nicely. Okay, moving on. So I'm tallying them up and I'm creating my bins to see how many is in each one. So when I create my histogram, I'm going to put, there's going to be 2 in the first bin and it's going to go up to 2. Or if I'm using percents, it's going to go up to whatever the first tick mark there is. The second one has 0. It's okay if you have a couple of bins that have zeros, but you don't want too many. If you have 3 or 4 in a row that are 0, you're probably going to want to make your bin width a little bit wider. Because once again, remember, we like them to be pretty. We like them to be visually appealing. So you want your bins to be wide enough that you don't end up with 3 or 4 empty ones in a row, but you want them narrow enough that you want them to choose a nice narrow enough so that it's meaningful and you're not ending up with just like 2 bins, but wide enough that it's still visually appealing. I'll show you some examples. I changed my bin width here to 5. So look what happens when I change my bin width to 5. I now have 3 in a row with nothing in them. We don't like that. You're going to end up with a histogram. Let me kind of sketch it here. Going to end up with a histogram that has a couple of really small ones here, and then you have nothing, and then you have a high one here, and then another high one there. So this big empty space here kind of makes it ugly. We don't like ugly. We would rather the using this one is more visually appealing than using this one. We don't want that big empty space in there. So try to make sure that it's wide enough that you don't have 3 or 4 bins in a row that are empty. Okay. So I'm going to let you know that the textbook and my PowerPoint has a way of choosing bin width that I don't use. I'm not a biggest fan of it. Now, if you like it, you are absolutely okay using it, but I want to let you know that it's not my favorite. So it's just weird and confusing to me. And I'll explain it when we get there, but I want to let you know ahead of time that now through this entire course, they do a few things that I don't like. And I'll always kind of let you know, but I'm not going to be upset if you use them because everybody's different. We all have different styles, and you might have a different style of mathing than I do. Just because I'm the one with the math degree doesn't mean that I'm the ultimate authority on everything, especially when it comes to visually appealing and choosing bin widths and all of that. I just have my own style. So when you are choosing your bin width, when you're choosing all of this, you're choosing your class width, you're choosing your lower class. So when you're choosing your lower class limit of the very first class, we like to choose an observation that is just slightly lower than the lowest value you have. This says convenient number. I say pretty number, whatever it is, just something slightly lower, something so it's a nice, pretty round number like the 670 was. So this is the part that I'm not the biggest fan of, and I'll show you why in a second. So to determine the class width, determine how many classes you would like. Now this says generally between 5 and 20 classes. I usually say between 5 and 12. I think 20 classes is too many, but I think it depends on what your data is. But generally between 5 and 12 is where we like to stay. So after you choose, so in order to determine your class width, this is their method. Take the largest data value you have minus the smallest data value you have and divide it by the number of classes you want. Now, this is all well and good, but let's give you an example of why I don't like this. So let's say we had what is it, 738 minus 672. So let's say that I want to have 10 bins. I want to have 10 classes. So if I do that, let me grab my calculator. I'm going to do 738 minus 672, and I'm going to divide it by 10. My class width would be 6.6. This is why it's annoying to me. I want my bin widths to be nice numbers. I want to use something like 10 or like 5 or like 15. Counting by 2 is fine also, and really depending on what you do. But in this case, with big numbers like this, I don't want my bin width to be 6.6. That's just weird. This is why I'm not the biggest fan of this. I personally like to choose the class width that I like and try it. And if it gives me big empty spaces in there, then I can just adjust it a little bit. I can adjust it a little bit bigger or a little bit smaller. So that is a little bit easier to do. And I'm going to show you how to do it in Excel because I'm not going to make you do any of these by hand. But I feel like choosing the width is just the better option here rather than choosing how many classes do I want and then mathing it out like this. But you do you. If you want your bin width 6.6, go for it. I'm not marking you down for it. All right. So, you're considering investing in a Roth IRA. Now, this was on your textbook. I pulled it out of there. It was on page 79 of the textbook. So, but you don't have to look at it. I'm just referencing, citing my source here. You collect the data on that in the table on page 79. It represents the 5-year rate of return in percent adjusted for sales charges for a simple random sample of 40 mutual funds. I'm going to construct a frequency distribution of the data. There it is right there. I have a nice, pretty relative frequency. Now, notice I created it with 1% for my bin width because it just made sense to me to do 1%. I do have two right here, empty bins. I have two empty bins right there, and I'm okay with it. When I did it with 2%, I don't have it here. I did it with 2%. I didn't really like the way it turned out. I did only end up with one empty bin, but for some reason I didn't really like it. So I was just like, you know what? I'm just going to go with two empty bins. If I did a 0.5%, it would not be pretty at all. I would end up with like four empty bins in a row. So this is Excel's histogram. I don't have labels on it, but I just wanted to kind of show you what Excel does by default. So, oh, I hate that. So down here, it shows both the lower and upper class limits. It shows you both of them, but it kind of doesn't because this one right here doesn't have 9.28 in it. It has 9.27, and then the next one has 9.28. The way it labels things is kind of weird, and there are ways to tweak it a little bit, and I'll show you that once we get to Excel. Now, I'm going to show you what you're going to see on your homework. I'm going to kind of draw it up here really poorly, probably because I'm not a great artist. So if I had my histogram here, and I'm just going to draw the first couple of boxes. Pretend that this is the lovely histogram we see below. See, I am such an artist. The way that you're going to see it on your homework is only the lower class limits are labeled. You will not see upper class limits labeled. So this would say 8.28. And then you would see 9.28 on the next one, then 10.28. It is just the lower class limit. The upper class limit, it just assumes that you know that the one before it butts all the way up against it. It's just assuming you know that. So only the lower class limit is labeled. I'm going to put this lower class limit. So you will know when you look at this, okay, the one that's labeled 9.28, The one before it goes up to 9.27, goes all the way up against that. And then 9.28 starts at the next one. So only the lower class limit is labeled. Any questions on this? Any confusion? Okay.
Is the lower class limit only labeled on all of these graphs?
So only on all of the histograms, except for the ones
Yeah.
with discrete. So like back on the ones discrete that we did back here,
Uh-huh.
it's because, let me see, where's the car? So this one, it's only one cars, homes with one car that are in those bins. So that's why it's labeled right there. But for example, if I made a histogram of this right here, I would label it. I'm just going to put random bars. These bars are not going to be accurate. I'm just putting random bars. This would say 25, and then this would say 35 and 45 and 55. So you'll only
Makes
see,
sense.
does that make sense?
Thank you. Yeah.
Okay, good. Great question. Yes, please ask questions because that's why we're in person. That's why we're on Zoom, so you can ask the questions. I don't know if I would have survived an online math class when I was in college. I needed the discussion. I was one of those annoying people that asked a lot of questions, and everyone's like, "Well, she just shut up already." That was me. So I definitely am cool with lots of questions. All right. We're going to do something now called a stem and leaf plot. We're going to put the histograms in your pocket and go with stem and leaf plots. I'm going to let you know. Stem and leaf plot is something we are required to teach. I have never found a use for stem and leaf plots out in the wild. It's, in my opinion, it is not the best representation of data. Now, I would love it if you are, I don't know, doing whatever you're doing and you find a data set that you think this stem and leaf plot would be the perfect way to represent this data. Let me know because I have not yet found any kind of data set that this is the best way to represent it. But we're teaching it. I don't know if there's any homework problems with it. I can't remember, but it will not be on the test. Stem and leaf plots will not be on the test. Obviously, I'm going to show you how to do it, but it's not going to be on the test. So, stem and leaf plots, the way that a stem and leaf plot is set up is that we will have what's called the stem on the left side, and it will be all but the last digit of a number. So, for example, if we have the data set of 147, the stem would be 1,4, and then we would have the leaf on the other side. So the rightmost digit forms the leaf. And so if I had in a data set 147, 148, 149, I would put 14 would be my stem, and then I would just put 7, 8, 9 on the leaf. Don't worry, I'm going to show you what this looks like. And you're going to end up with your little like tree-ish. So it doesn't make much sense when it's in words, but it'll kind of make sense once we're doing it. Okay, so I'm going to show you a data set. There we go. There's my data set. So this data set represents the time between eruptions in seconds for Old Faithful, geyser in Wyoming. We already were there once. Just a second here. I needed to pull this up on my other computer so I can have the data set while I am writing it down. Just give me 1 second. There we are. I need to have it visual on the other computer so I can write them down. So I have these ordered from smallest to largest because I'm going to need it from smallest to largest. So the stems of my stem and leaf plot is going to be like 67 and then 60 and then 68 and then 69, and the leaf will be the ones place. So I have it set up right here. The reason I have 72 listed twice because when we have a number that has a ton of data values that fits in its spot, then we'll sometimes split it in half, and then the top one this one right here would go to 724, and then the next one would start at 725. That way we can make it not be super long. So the way that I'm going to set this up is the first one is 670, and then I'm going to have the data values coming after it. So I have a 672, then I have a 678, and that is all in the 670s. I don't have any 680s. So that's just going to stay blank. Then I have a 695, and I've got another one. I actually have three 695s. Yes, you list every single one, and you list them in order from smallest to largest. I have a 696, 698, two 699s. Oops, I just put those in the wrong spot. I'm moving them. Uh-oh. I'm going to move them. I have a fancy tool that allows me to move them down. Sorry about that. Okay. Now I'm going to go to 700s. I have two 700s, and I have 702s. I have two of those, two 703s, a 706, and a 709. I have a 708 also. Let's see here, 8, 9. Okay. Now for the next one, I have two 711s, a 13, two 14s, a 16 and 18, and a 19. So for once again, remember with the 720s, I said that one of them was going to go to 24, and then the other one's going to go to 25. So I have 0, 1, 1, 2, 2, 2, 3, 3, and jump down for the 725s, 5, 6, 6, 8, 9. Then the 30s, 0, 1, 3, 5, 5, 6, 8. All right, so that's my stem and leaf plot. Whenever you create one of these, you also have to create, that's a 5, that's ugly. You also have to create a key. So you write the word key, and then I would say, you choose a random value. It doesn't matter which one. I'm going to choose 714. Say 714 represents 714 seconds. I probably shouldn't have chosen one with a 1, but there we go. So when you're creating this, as I said, it's always the smallest to the largest digit in the ones place. Yes, you repeat them if you have repeated numbers, and they're in order from smallest to largest. And this is just how it looks. So this is my stem. So this is 670, 680, 690, etc. And then the leaf is all the ones in the ones place. So a lot of times when you're creating these, it's tough to create them in the order from smallest to largest first because I had my data set already organized smallest to largest, which can be pretty time consuming. In fact, it was. Most of the time, your data is not going to be smallest to largest. And I'm going to show you what we're going to do there when that's the case. And I'm going to do that on the next one. Okay. So here I have the unemployment rate in all 50 states. I don't think DC's in here. No, yeah, it is. DC's in there. So 51 states. And I don't know what year it is, but these are just the unemployment rates. In this case, we have a decimal. So my leaf is going to be the number after the decimal, and my stem will be that whole number before the decimal. So in that case, that's what my stem and my leaf are going to be. So here is all the data disorganized. So what I did was just went from the top to the bottom and I just put them in their spots. So I noticed that, so the first one was 4.7, so I put 7 after the 4. Second one 6.8, I put 8 after the 6. I just put them in all disorganized. You can't leave it this way. So usually what I will do is I'll do it all disorganized just like this, and then I'll just do a second one and organize it. So sometimes you've got to draw them twice. I'm not going to make you draw one, but I'm just trying to give you an idea of what we do. But this one does not yet have the key. So once again, right key, you choose a random value. I'm going to choose 53. 3 represents 5.3%. That's weird. That was a lovely spelling. So you have to have the key because otherwise someone's going to look at this and be like, I have no idea what this big jumble of numbers means. So as I said, I have not found really a lot of value in stem and leaf plots. I haven't found a good place for it, a way, for representing data. I don't know exactly why we use it, and I've done a little bit of research in it also. I have not, still haven't found a good answer to my question. But
Am
if,
I the only one who thinks they're a little confusing or like
and they are.
maybe I don't know. I'm thinking slightly unnecessary. Probably not unnecessary. I see how it would help organize numbers and data. It's just I don't know.
I 100%
Hard
agree
for me
with
to
you.
understand.
They're not they're not super intuitive. You look at it and you're like, this just looks like a jumble of numbers. It doesn't really make a whole lot of sense. Now,
Yeah.
if you've made a few after you make a few of them, yeah, they kind of make sense, but I still don't see value in them. Now, they wouldn't have survived so long if there wasn't some value to somebody, but you are not going to be tested on it. I don't believe that there's any on your homework. So basically, you just kind of look at it here and you say, okay, I know a stem and leaf plot exists. If you saw one in the wild, you'll be like, oh, yeah, that's a stem and leaf plot. That's that thing. How weird. And then you'll move on. That's,
Also, it was in the my open math homework, and I saw it, and it didn't show the key the way that you represented it. It showed like, oh, this in 10,000s, but I was looking for the key the way you explained it, and I was like, oh, what?
oh, so
So I
there
would,
is one in my open math?
I believe so.
Okay, I'm going to take a look real quick just because I'm dying to see it. Okay, I'm guessing it's the 2.2 homework because
Yes.
it wouldn't be in 2.1, I don't think. Let's take a look. All right, let's see. I'm scrolling. Okay, that's not it. And see, the thing is there's like more than one version of the homework, so maybe not. No, that one's not. That's a frequency, a histogram. Oh, yes, there it is. That there it is right there. Okay, let's take a look. Yeah, they didn't give you a key. That's so rude. And so they just want you to finish it. So you would just take the fives, and it looks like there's just, well, mine has a 51 and 55. So
I
what I would recommend if you get this question, put them in here out of order and then just maybe fix it after they're in there or write them down on your paper and fix it. Because I can see I have a 51, 59, and a 55.
also, I
I'm,
think I'm referring to question 17 below
oh,
that.
okay. Oh, yeah. That's
Yeah.
rude too. They didn't give you a key. What the heck?
That's what I was saying.
That's,
Good
and
catch.
I
That's
took
awesome.
like so many stats classes in college, and every single one of them pounds it in your brain. Make sure you put a key. Ah,
I know, and I kept getting stuck on it because I didn't see the key, but I got through
I'm so mad.
it.
So I guess there are two questions. I'm sorry. But so if you get stuck on them, message me. I'll help you. Just click on message instructor. I will help you. So I guess there are two questions. And this one's weird. Stop. Okay, sorry. I'm gonna get stuck, go down a rabbit hole. Things like that happen to me. So, all right. So there are two questions, but I can promise you they are not on the test. The homework is pretty low stakes, and you can keep retrying and keep retrying, and if you need to hit a different problem. So that's the nice thing about the homework is technically you can, I think gives you 99 chances if you keep hitting give me another problem. So you can get full credit on your homework unless you're just running out of time and it's like, you know what, I don't care, it's a point. But I'm happy to help. Please do not feel bad if you ask me 10 questions in one day. I don't get irritated about that at all. The only thing I get irritated about is when somebody claims that they can't get me to help them, but they've never asked me for help. Trust me, it happens. Why won't she ever help me? Like, I've never gotten a message from you asking for help. That's the only time that I get irritated. And it's pretty rare. I've been teaching at RCC for 8 years and it's happened maybe 3 times. So it's not like it's all common, but that's the only time I get frustrated. All right, I'm going to move on. Okay, shape of distribution. This is super important and it doesn't go away. This does not go away. So understanding the shape of distribution is super important. Thankfully, it's not super difficult. So we're going to start with uniform distribution. So when you look at a histogram, see this one does good. This one has your lower class limits on there. Anyway, when you look at a histogram, this one just looks like a rectangle. This one is called a uniform distribution. It has this nice rectangular shape. Now, um, statisticians do not deal in absolutes. Nothing is really absolute. So most of the time, a uniform distribution is not perfect. Sometimes we'll have something slightly higher, like maybe it goes just slightly up there. Maybe this one goes slightly down there, but it's mostly uniform. So if it's mostly uniform or it's really close to uniform, we will call it uniform if it's super close. But it's basically this nice rectangular shape. We will call it uniform. So it is uniform and it's also symmetric. It's symmetric because if I cut it in half, let's pretend that's in half, I can move that. If I cut it in half, if I folded it, it would land on top of itself almost perfectly. And once again, it doesn't have to be absolutely perfect because we're statisticians. We don't deal in absolutes. It's one of the things that was hardest for me as a person taking math classes. Every other math class you take, there's exact right answer and everything is absolute. In stats, we do not deal in absolutes. And it was kind of hard for me. It's not just black and white. Okay, moving on to the next one. This is bell-shaped or symmetric. It is also called normal. So this one, if I could draw a nice, pretty bell over top. It is the highest frequency is right in the middle. It tails off on both of the ends, so it's taller in the middle. And this is not perfectly symmetrical. If I drew a line down the middle, which is somewhere around right here, it's not going to perfectly fold on itself, but it's going to be pretty close. It'll be pretty close. It's mostly symmetrical, relatively symmetrical. All those adverbs, we like adverbs. So it can still basically fold on itself and it's got this nice bell curve. You'll see a big difference between the bell-shaped and the ones that are skewed. So this one is bell-shaped or normal. This one, now, it might annoy you, but this one is skewed right. It feels like it should say it's skewed left because most of the data is on the left, but we're referring to the tail. The tail is on the right, so it is skewed right. So the shape is based on where the tail is. So my tail is skewed right, so my graph is skewed right. My distribution is skewed right.
Is that called a skewed right distribution?
We
Or
usually just say that the distribution is skewed right. I mean,
okay.
you could call it
Okay.
a skewed right distribution. Nobody's going to get mad about that. We just
Kind
generally
of a
say
silly
this is
question, I just
no,
realized.
it's fine. No silly questions. Except
Thank
for
you.
my cat asking me to feed her when I just now filled her bowl. So that was silly for her. She's over here poking me because she wants me to fill her bowl that I just did. All right, skewed left, same thing. We're looking at the tail. The tail is longer on the left, so it is skewed left. The peak is like moved over to the right, but my tail is what we're going by. The tail is on the left, so it is skewed left. We only have 4 more slides. We are almost there, and then we'll do our lab, and then we're going to be done. Y'all are doing awesome. All right. And it's so much better when I can write on this on the slides. So much better this time. All right, let's take a look at this one. Think about what we think the shape of this distribution is. I can draw a nice, pretty bell over the top. That was not a perfect bell, but this one is bell-shaped. So usually, I mean, you can see that we have tails on both the right and the left. and they're pretty close to the same size. And that's kind of how you can see that it's not the skewed. Plus the majority of the data is right there in the middle. But this one right here. This one is skewed right. This one has the tail over there on the right. So this one is skewed right. Bam. Right. This one right here. Process of elimination. This one is skewed left. That one is skewed left because the tail is there on the left. I bet you can guess what the next one is without me even flipping to it. This one is uniform. It is a nice, pretty rectangle. It is uniform. I think that was my last slide. That was my last slide. All right. So we're going to do the lab next. That was the last of the new material. But before we do the lab, any questions on what we've covered in class today? The lab's my favorite part, so I'm kind of excited. I get excited about weird things. You'll get used to it. It's like every week I'm like, oh, this is my favorite. People are like, yeah, you said that last week. Yeah, it's all my favorite. It's kind of like me telling all my grandkids that they're my favorite. They are. Each one of them is my favorite. There's 9 of them, so I have 9 favorites. They're all tied.
Aw.
They are. They're ranging in ages from 12 and a half all the way down to 4 months. So I've got a really, really wide range of grandkids. They're pretty great. Okay. Now, you're welcome to follow along with your own lab if you already have the materials, already have it in there, or I don't know if you've already collected your data. Uh, but so I'm going to start with categorical. The way you get to the lab, I'm going to go there first because sometimes it's confusing. So I'm going to go into week 1. Now, if you need to watch the instruction again, you can either come back to the Zoom or there's a video right here that has the instructions for how to do the lab. So if you just click on the lab, um, okay, take a second to load content because I'm on Zoom and it everything takes forever to open when I'm on Zoom. Okay, I'm going to do a teacher. I'll just do start. This lab file is right here. So you're just going to click on that and it will download that lab file onto your computer. And you have to use Excel. You cannot use numbers or Google Slides or Sheets, whatever it is, Google Sheets. Google Sheets definitely does not have the functionality. Numbers is tough because I can't open numbers on my PC, and I don't think it has all the functionality either. Apple's products are not super great when it comes to like word processing and Excel and all of that. I like a lot of the Apple stuff, mostly because it's forced on me by my school district, but it's not good and it's spreadsheet stuff. Excel is the gold standard. If you're going into business or anything like that, they all use Excel like every day or accounting or whatever. Um, so that's the Excel file right there. I'm going to go back here. So some of my data is made up. I'm going to admit it. Don't make up your data, or if you do, don't tell me that you made it up. So, but I didn't just say that. Do not spend too much time getting data for the early labs. Because a lot of people like to poll their friends for things. Yes, thank you, Amanda. So, um, just if your friends are going to get annoyed by you polling them regularly, don't do it yet. Wait until your final project, which is a few weeks out. But if you're polling them for every new lab we do, they might get kind of annoyed. So, and if you start thinking of ideas for, hey, this is something I would like to look into deeper with this stuff we're learning in class, write down your little ideas because once I assign the final project, you might have a list of ideas already of, hey, this would be a cool thing to look deeper into. So my categorical, what I did was I figured out yes, true. So I figured out what color, my favorite colors my friends had, and I wrote them here. Your raw data goes on the left column right here. You need 20 data values. That's it, just 20 data values. And I have my 20 favorite colors right here. Just typed them in. It's completely raw data. After that, I organized them. I counted how many of each color where it showed up, and down here's where you're going to do that. I listed each of the colors and how many times they showed up in this column right here. Okay, my population is friends on Facebook. My population is not favorite colors of friends on Facebook. That's not what it is. The people I'm studying are my friends on Facebook. The variable I'm studying my friends' favorite colors. The units of my data, now categorical really doesn't have units. So units are things like feet, pounds, ounces, dollars, things like that. But you can put the word color in there, or you can just say no units. But I want you to acknowledge that you looked at that box, but you can write no units or NA. But I want you to acknowledge that you've seen that box and that you don't have units. On letter D, why are you sure your sample data is categorical? Refer to the definition of categorical and give me an explanation based on that definition. It should be in your notes. Use that definition. And how and where did you get your data? I don't care that explain how well your sample represents your population, especially since explain is spelled wrong. I just now noticed that. Anyway, I don't care about that part. All I care about is where did your data come from? If you went to a website, give me either the link or the name of the website. So I went to NFL.com and I looked at the main color in the logo of 20 different teams. Whatever you did, you can put NFL.com or you can put the link to it, but let me tell you, Google is not a source. Please don't just put Google. Google is not a source. All right, so now I'm going to create the pie chart. So I'm going to go down here to this table that I created, and I'm going to drag my mouse so that all of this is highlighted. Both columns, the X and the F don't need to be highlighted, but both of these columns are highlighted. I'm going to make it a little bit bigger. All right. Now I'm going to come up here to insert. When you go to insert, since all of this is highlighted, it knows might want a chart. On recommended charts, 99 times out of, no, maybe not 99 times out of 100, 85 times out of 100, the chart that you want will be here. See, there's my pie graph right there. If you don't trust that, there's a picture of a pie graph right here. Let's just go basic. I'm going to go basic. And this is beautiful. I love this. This is great, except my labels are funky. I'm going to just dragging this to fit it. My blue is red. The red is light blue. Brown is purple. Purple is blue. I don't really like all that. I'm going to fix that in a minute. I want you to put percents on your chart. So if you go up here to the chart design, pick one that has percents on it. Just pick one. I'm just going to pick that one. That puts percents on. I want to see your percents because it's a lot easier to read. Remember that you have to have a title for your chart. So I'm just going to say friends, favorite colors of friends. Favorite. I really can spell, trust me. Okay. Now, this is lovely. I like this, but what I don't like is I don't like that all these colors are wrong. And I'm going to double click. I just double clicked on my entire pie and see this right here. I'm going to change my fill colors. So I'm going to just click on each one. So this one right here, it's red right now. I want it to be blue. This one right here, this one should be purple. I'm going to change it to purple. I'm not going to be mad at you if you keep them wrong colors. It's not going to, I'm not, oh, that one's supposed to be purple. I'm not going to be mad about that, but it is kind of annoying, but nobody's going to be mad about it. I'm just going to be like, what the heck are they doing? But, you know, some people like to be silly. So if you be silly, go be silly. Okay, this one, whoops. This one right here is supposed to be green, I think. Uh-oh, I didn't do that. Command Z. Okay. I accidentally clicked on the whole pie instead of, yeah, so I'm just changing them. So that, okay, this one right here should be red. All right, there we go. Good enough. So you can change the colors to be the correct colors. You can do whatever you want. There's a whole lot of style options up here. Feel free to be creative. There's a whole lot of things. You can also choose color palettes. So feel free to be a little bit creative, but that is my pie graph. Any questions on pie graphs before I move along? Okay. Now histograms are going to take a little bit more finesse, but I'm going to click on continuous data now. So my data represents the magnitude, maximum magnitude of earthquakes in different countries around the world. I have way too much data, but it is what it is. I'm letting you know right now, this box up here, they've changed the way that things work in Excel. With newer versions of Excel, things work differently. So you do not, this box right here, you do not have to put anything in it. Leave it blank. You don't have to do anything with that one. I am going to want you to fill in your interval width up here, which is your bin width. I want that filled in, but you don't have to do this piece right here. So you can just leave that blank. Now, if you want to do it, go for it, but you don't have to. So my population is countries of the world. My variable is magnitude of earthquakes. Now, normally, most continuous data will have units, feet, miles, days, degrees, whatever. Most of it will have units. So put your units right there. Mine doesn't because magnitude doesn't have units. But I mean, I probably would just put magnitude there, but it doesn't have units. Now, continuous letter D, use the definition of continuous data. Use that definition to fill that in. Once again, tell me how you got your data. You don't have to explain how it represents your population. All right, let's do a histogram. And I'm going to show you how to get pretty numbers also because I like pretty numbers. I'm going to show you how to trick the system. Okay, so once again, drag your mouse all the way down. I have way too much data. You only need 20. So I'm an overachiever, as you can tell, because I have, I don't know, 100 something. I went too far. Uh, 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 uh. I am the person in my writing classes in college that they said 5 to 8 page paper, and I wrote a 12-page paper. That's me. I'm that person. All right. So go back to insert. 85 times out of 100, it will know what chart you want. You don't want the histogram with the weird line on it. You want the histogram without the weird line on it. If you don't want to use that, if you click on this one right here, you can see the nice pretty histogram. Okay, the histogram's going to need some work. Now, before we add chart titles, make it pretty, change your colors before you add chart titles because any work you do is going to be erased after you choose, if you change your style. Any work you do is going to go away. Any of the extra stuff you do is going to go away after if you decide to change your style. I don't want the numbers on there. I don't want those. Okay. I don't even know how to get rid of them. Okay, whatever. Okay. Let's go with gray. Okay, so here's my lovely histogram. Now remember I told you we need to have axis titles and we need to have a chart title. So let's go with that. I need to go up here to the left, top left, it says add chart element. Click on that, go to axis titles. My primary horizontal, I need a horizontal axis title. Do it again, add chart element, axis titles, I need a vertical. So this is going to be earthquake magnitudes of the world. Earthquake, whoa, I don't know what I did. Earthquake magnitudes of the world. Everybody's, well, I didn't mean to do that. Everybody's vertical axis is going to be frequency. If you don't like how small that is, you can click on it. Go back, click on it. Highlight this, and I'm going to make my font size bigger because I don't like that I can't see that. Okay. Now this one's just going to say magnitude. Magnitude. I can't even see it to spell it. Could be my old eyes because I am a grandma, you know. Us grandma people are pretty old. We got old eyes. Fun fact, I didn't actually start wearing glasses till I was a grandma. Correlation doesn't equal causation. Okay, so I personally, my bins are okay, but we might want to change our bin widths. So in order to get the window that I need to change my bin widths, I'm just going to double click on the body of my histogram. Just double clicking on it opens up this menu here on the side. So notice here it says bins, and I'm going to go to bin width. And I can change my bin width to whatever I want. I want to do 0.5. Do I like the way it looks at 0.5? Let me scroll over here. Now that might be too many. Maybe I want it to be 0.75, or let's say what 1 looks like. Here you can play with it. I don't think that's enough. It might have known what it wanted with the 0.75. I kind of liked that one. So play with it here until you get it the way you want. So let's say that I decided to make it 0.2. Am I going to get blank ones? I was trying to make it so that I got blank ones. It looks like I don't. That's way too many though. So just play with it until you make it the bin widths the way you like it. I like the 0.75. I'm going to leave it on that. And then I'm going to go up here and I'm going to type 0.75 because that's the bin width that I chose on my interval width. That's the bin width I chose. That's what I'm going to do that. There's other things that you can do here. Like I could make, where is it? There's a spot where I can make my, I think I need to click on a different, somewhere in here, there's a place where you can like make this space in between um, between your bars. Yeah, here it is. Wider. I thought that was in there. I don't know. There's a place where you can do that, but just, you can poke around, play with it, see what other kinds of options are in here. Maybe there's something that makes it cool. I want you to try to get creative. I'm going to get out of here. I'm going to show you how to trick the system. So notice how my smallest value is 4.4, and that's where it starts. I don't like that. I want to have a pretty number. Remember when I talked about finding a pretty number below? I wanted a pretty number there. So I'm going to trick the system. I can change my lowest value to be what I want my lower class limit to be. It's still going to be in the same bin and it's still going to register the same amount in the bin. It's not going to affect the way my histogram looks. What I usually do is I'll put the correct value. So look up top left. I put the correct value next to it and then I just change it to a 4. I change it to the value I want. So I want that lower class limit to be a 4 instead of 4.4. So I just change my lowest value to a 4 and just put 4.4 next to it so I know that that's the actual value. Now look at my beautiful histogram. Now it goes from 4.4 or 4 to 4.75 and it's nice and it's pretty like that. I'm just kind of tricking the system to make it pretty for me. And I didn't really affect anything. My bin widths are the same size, or my frequency in each bin is the same size. It is fine. It's still in the bin that it would be in, regardless, because that bin is still 4 to 4.75, and 4.4 would be within there, so it's okay. Questions on continuous before I move? Okay, discrete is the fun one because you get to really be creative. All right. So, um, once again, I polled my friends on Facebook and asked them how many children they have. So my population is friends on Facebook. My variable, oh, I forgot to tell you, This is why are you interested in your variable? You don't have to be interested. You can ignore that question. I don't expect you to be interested in it. The reason you're interested in it is because you need to get credit for this lab. That's my guess. My guess is you're probably not going to be super interested in any of your variables. And now if there is some cute little reason why you're interested in it, share it with me. I love little stories. So, if there's a fun reason why you're interested, tell me about it. But otherwise, you don't have to answer that question. Okay. So units of your data, you might not have units. You probably won't, but I could write children here, or you could just say no units or NA. I want you to acknowledge the question, but if there are no units, you could write no units. The way I know my sample is discrete, look at the definition in your notes. I want the information there. How'd you get your data? Same question, and I don't care how it represents your population. All right. You can organize your data here if you want, depending on what kind of graph you're going to use. I have each value here and the frequency here. Now, here's the fun part. You can use any kind of graph that represents your data well. So you're going to play with the graphs. You're going to go up to insert. You're going to look at all the graphs. You're going to play with a few of them. I want you to choose what represents your data well. And it's okay if you go back to the ones we did before. It's okay if you have a pie chart again, but I want you to play with the different graphs and just land on the one that you think best represents your data and be creative. That's all I'm looking for is for you to get a little bit creative here. But make sure you have labels. Labels are important. Give me labels. And that's all I have for you. So questions on the lab? Anyone? Oh, that's cute. I love the little thumbs up flying through there. That's really cute. Okay. Um,
Sorry, if we have questions while we're doing this, we just would we email you or
you can
message
message
you
me.
and just ask?
You can message me through Blackboard. You can click on message my instructor through my open math. You can email any of those work.
Okay, thank you so much.
You're welcome. And I try to do my best to check messages frequently. Sometimes, like weekends, sometimes it takes me a little while to get to you because I usually have a house full of grandkids on the weekends. It's something I must do. I must teach them board games and silly songs. It's kind of my job, my purpose. Um,
That is so sweet, so wholesome.
Maybe you stats when they're older.
my oldest grandson, he is a seventh grader and he is in advanced math. He's taking Algebra 1 right now. And he will frequently FaceTime me and we will work through math together. It's so much fun. And then
That is so cool.
we also trade Pokemon on Pokemon Go.
I love that.
Yeah, my grandkids are amazing. They're the best people I know for sure. And I would love to have more and more of them, but Christmas gets really expensive. So
I can imagine.
that's why I have two jobs. All right. So any questions at all on lab or the lesson or anything else that is on the recording because we're still being recorded. So any questions for on the recording for anything?
So I saw you linked a video to plotting histograms with the TI-84. Um, is that going to be part of the quiz
No, it's not
at all?
required to do it. It was just something, just a little bit of information I gave you just so that you know how to do it if you want to.
Okay, thank you.
Uh-huh. That was a good question. Thank you. Anyone else? Okay, I'm going to turn off the recording if I can remember how to do it. Because I took let's see here. Where's my recording button? Stop recording. There it is.